Hello everyone, welcome to Intrinsic Intelligence YouTube channel. Today we are going to discuss on k largest element in an array. So k could be anything. It could be first largest element in an array or second largest element in an array. Let's see how we are going to find it. In the first example, we have 1, 23, 12, 9, 30 to 150. So k is 3. We are going to find third largest. So the first largest is 50, second largest is 30, third largest is 23. So the output should be 23. In the second array, it is 12, 3, 5, 7, 19. Kth largest is 2. So first largest is 19, second largest is 12. So the output will be 12. So we are going to achieve this using a heap, and we are going to use minimum heap. In Java, how we will achieve it? Using priority queue. First, we will see how this can be solved in a minimum heap in an Excel sheet, basically, and then we'll move on to the implementation. So consider we have 12, 3, 4, 19. So these are the array we have. And then consider k is 2. So we can consider this as 2, and this is an array. Now what we are going to use is minimum heap as our solution. So we will iterate in the mean. Iterate 1. Okay. First we will take 12. 12 will be the root element of this iteration. So what will be the second iteration? It will be 3. So now the root is 12 and here it will be 3. So the left value will be 3. So 12 is root, left element is 3. Now in the iteration 3. So 12 and in the iteration 2, as it is a minimum heap, it will be something like this. So when I insert 3, 3 will be, because 3 is minimum and 12 is greater, so it will be, the first iteration it will be 12, in the second iteration it will be 3 and 12. So in the third iteration, it will be 3 and then 12 and then 4. Now comes the real problem. We have root as 3 and then we have left as 12, right as 4. Now we have to find k as to second largest, but what we will the trick here is at any point of time just keep the minimum heap as two elements and remove it. So the root element is 3. After removing 3, what will happen is it will be 4 and then 12. This is how the heap looks like. Now this iteration we'll see. Iteration 4 will be the final one. Now we have 4, 12 and then 19. We'll take it. So we have 4, we have 12 and then we have 19. Now we need second largest. Now we need to remove the root 4. Now what happens? The minimum is 12 and then 19. So this is our final heap. It will be root as 12 and the right element as 19. And this is our final result. Basically, I'll just highlight it in a green. So this is the result. And what is, suppose now, what we need in here, we have 12, 3, 4, 19. We need second largest. First largest is 19, second largest is 12. 12 is our root. If we put minimum heap dot peak, it will be 12. Hence, we got the required result of 12. This is how minimum heap works. So we are going to solve this project using this minimum heap. Let's deep dive into the coding part. I have created a kth largest element class. I have created this method where we are going to find the logic. I have put time complexity and space complexity. We'll come back to it later. I have this array 3, 2, 1, 5, 6, 4. So k is 2 is the second largest. So first largest is 6, second largest is 5. So I have created all the basic codes. Now we will go into the code. First we will create a minimum heap. How do we create a minimum heap in Java? So we can create it using Q. We'll create Q as an integer, and then we have, I'll just put min heap here, and then new priority queue of integer. So it is not, now it is a minimum heap. What we will going to do is, int value of this input array. So what happens now is we will put this value inside the heap, in heap. So we will directly include minimum val, and the important logic is, if minimum heap dot size is greater than 2, or greater than, just put k, k is what, 2, and if it is 2, then minimum heap dot, so at all point of time we will keep the minimum heap as 1, and then 2 sizes of k, and now we have uh, min dot peak. Well, let's just execute this. So we should get a output of 5, which is the 5. We got 5, which is the second largest element in an array. We got 5. And what will be the time and the space complexity? So time complexity will be order of n log k. The size where we keep them in at 2, and n is the number of elements in an array. So the space will be order of n additional memory. So we are inserting the input array and into the minimum heap. So it should be order of n. To be precise, it will be order of k, because we are having 2 elements at any cost. Thank you all for watching this video. Have a very good day.